Okay, this is 7.7. We have a deck of 8 cards. Some of them are white, some of them are gray. So letter A, if a card is drawn at random, what is the probability of getting a white? I don't know if you guys can see those colors, but we have 5 of them that are white, so 5 out of 8. Okay, and then the next question is conditional. So what is the probability of getting a white given that the number is less than 7? So if I wrote this out, I could say the probability of white given that the number is less than 7. So this has already occurred. So imagine I shuffle these cards and I reach in and I pull one out, but I don't show it to you, and I say, this card is less than 7. What is the probability that's a white? That's what the given means. So we're going to circle every card that is less than 7. And then among those, what's the probability of getting a white? 4 out of 6, which simplifies to 2/3. All right, let's do one more of those. So we have a bag with 6 marbles in it. What is the probability of getting a number greater than 4? So that would be these 2 marbles. So it'd be 2 out of 6, or 1/3. What is the probability of getting a number greater than 4 given that the marble is gray? So we're only allowed to look at the grays. What's the probability of getting a marble that is greater than 4? Would be 2 out of 4, or 1/2. You guys understand those givens? Do you need to see another one? One more? Okay. What is the probability that the dart lands on gray? So there are 10 spots. 1, 2, 3, 4, 5, 6 of them are gray. So 6 out of 10, or 3/5. What is the probability that the dart lands on a gray slice given that the dart lands on a number that is less than 7, but less than 9? So I'm only allowed to look at those. And there are 6 grays and 8 total spaces, so 6 out of 8, or 3/4. We get it? Okay. All right. These are a little bit tricky. We need to write a two-way frequency table. Okay. So we're looking at female and male, and we're looking at engineering. What's the other one? Not engineering, I guess. So 55% of the students are female. So these two boxes add to 55%. 17% of the students major in civil engineering. So these two add up to 17%. 8% of the students are both female and civil engineers. So this is an 8. So how am I going to figure out this box? 55 minus 8, which is going to be 47. And this one is going to be 17 minus 8, which is 9. And if we needed to, we could figure out the remainder because all of these have to add up to 100%, right? So if I needed to, I could figure out that box. Let's see if we need to or not. So what is the probability that a randomly selected civil engineer major is female? So this says we're only looking at the civil engineers. So we're looking at this column. What is the probability that a civil engineer is female? So that would be 8 out of 17. So 8 out of 17, and it wants the decimal. What is the probability that a randomly selected student majors in civil engineering? Well, that would be all of the civil engineers, which is 17%. Okay, these are a little bit tricky, so we'll do several. Okay. All right. So we're looking at adults in California. So college graduates and not college graduates. And then internet users and not internet users. So 26% of all California adults are college graduates. So this is 26%. What, if we needed to, what would this be? 100 minus 26. So this would be 74%. I don't think we're going to need to know that, but you could figure that out. And 31% are regular internet users. So the internet users are 31%. Also, 20% are both college graduates and regular internet users. So this is 20%. And doing subtraction, 26 minus 20 is 6%. 31 minus 20 is 11%. And then if I needed to, 74 minus 11 would be 63%. And if you look, if I add all of these up, they equal 100. At least they should. Yeah, they do. So, letter A, among California adults, what is the probability that a randomly chosen internet user is a college graduate? So this is saying we're only allowed to look at the internet users. So we're only looking here. What is the probability that those people, randomly picking one of those people, will give us an internet user? So that would be 20% divided by 31%. And what is the probability that a California adult is an internet user, given that he or she is a college graduate? So we're only allowed to look at the college graduates, and we want internet users among that group, so that would be 20 divided by 26. Good? Let's do another one. All right, so we have news readers. Well, let's just call them readers and not readers. Okay, and then we have TV and not TV. So 23% of college students read internet news on a regular basis. So this is 23%. 81% watch news on TV. So that would be 81%. 20% do both. So this would be 20%, which means 3% here and 61% here. What is the probability that a randomly selected college student reads internet news regularly, given that he or she watches the news regularly? So we're only allowed to choose from those people. So that would be this group here. And we want to know what's the chance that they read the news if they're a TV watcher. So that would be 20 out of 81, and then whatever the decimal is. What is the probability that a student watches TV news regularly given he or she is a reader? So that would be in this group. So 20 out of 23. All right, that's it.